All right, well, welcome everybody to Astronomy Daily Live. It is 2 hours UTC on the 4th of September, 2018. It's incredible that we're already into September. Things continue to just move forward, and totally amazing. So welcome everybody. Come on in, join the circle of friends here who share a common passion for the science of astronomy and science in general, and all things science, even science fiction sometimes, right? So yeah, so hope everybody's doing well. On the panel again is Bobby. Hey there, Bobby.
Hey, what's up?
Everything's going well down there. You staying dry?
Yep, staying dry.
Okay, yeah, you got a little bit of tropical excitement there. So yeah, just shouldn't be a big deal, but it probably is going to get a little bit wet. So if it isn't already. So
I
that's
can
cool.
see Uncle Bill in the chat right now.
Uncle Bill's in
Coming
the
to join
chat.
us?
Cool. Yep, come on in if you want to, Uncle Bill. Yeah,
Oh, I finally got the Hearts of Space working again.
Oh, good. Yeah, those kinds of problems just sort of were surprising. So yeah, I'm glad you were able to get onto that. Yeah, we get tropical storms here too, right? They come up the Western Pacific, um, usually, like in the form of a hurricane, right, down south of me. And as they move north, they usually weaken, and by the time they they hit land, they're usually pretty weak already. So uh, all that we get here is just rain, right? Which in the desert is welcome. And sometimes that can go a little bit far. I know a couple of years ago, maybe 2 years ago, 3 years ago, we had four we had four tropical storms blow through. So we had rain from like July to like almost the end of November, just constant rain because of these tropical storms, not because of the monsoons. And the monsoons are actually starting to slow down now, a little tiny bit. Um, sort of seeing signs of that. But the tropical things continue, and so yeah, a couple of years ago, we just got hit, one after another. It was pretty amazing. So yeah, speaking of monsoons, it has cleared up for tonight. So actually, what I actually sort of meant this to do last time it was clear a few days ago, and that is I've been loaned. I've got a coworker that has had a telescope for many years, and he's never been able to figure out how to set it up and get it aligned and everything else. And so
Okay. There's Tom Van Scotter, Andy Conley, and Arwada in the chat.
Oh, nice to see everybody there in the chat. Hope you're doing well. Yeah, so as I said, I've got a coworker who has had this telescope for several years. Um, hasn't been patient enough with himself to figure out how to set this up, and all that. So he has loaned it to me, so I can figure it out and then show him. And I'm, uh, well, I'm going to say exactly what I told him, and that is I can show him, you know, no problem, right? But it's him that's going to have to get out, set it up, go through the procedure, right? There's a procedure to get this thing um, um, totally aligned, right? So it'll track the stars and everything else. So yeah, here, let me show it to you. I'm gonna put the mic down. My microphone stand is on its way. It's on its way. It should be here, I think, in a couple of days. So that will hopefully free up both hands, right? So I
Okay, and before
yeah.
you do it, if anybody can hear my TV, I would not mind turn it off until after the program, because what it is, I'm actually watching the action from Gordon and stuff as it's gonna hit between New Orleans or at the Mississippi Alabama border.
Oh, amazing. Yeah, you know, either that, or if you just want to mute yourself, that'll work too. So yeah, I can sort of barely hear it. But yeah, people in the chat, if you want to yell at Bobby, there he is, right there. Okay, so I'm gonna show you this telescope here. It's a refractor. So here we go. Hold on. It comes in its own little backpack carrying case. So here, I'll do yeah, let's do the whole thing here.
Interesting bag. We're in a state of emergency in Louisiana as well. Just watching it right now. Oh, that's nice. Like it like that. I said I like it like that. Wow, that's good. I can even see your screen. What's up, Patrick? Batten down the hatches? Times like these, I'm glad to lift up upsets out of water.
There's the telescope and the mount, right? It's an alt-as mount, like that. And then what you do is you put it on this tripod.
Okay. And once to put together, it looks like it's already together. That was out of water. Ah. I hope it's one of those easier ones and stuff. The one that just click. Ah, just had to screw. Okay.
In the backpack in this little front part here. I'm going to do this in both hands. Hold on.
Your co-worker could not figure that out? What the deuce? Just need 2 thumb screws. No tool needed. Interesting. The control panel. Interesting. That's all I want to ask is, what exactly does that person do for a living? I don't know. Can anybody in the chat hear the TV?
I can hear it a little bit. So, yeah, this is a nice little refractor, and I tried to get the webcam up there to focus on the lens here, but I'll just read it off. So it's a 60 millimeter f5.8. 5.8. So it says here that the focal length is 350 millimeters. All right, so this is called the Meade ETX-60 telescope. So yeah.
Okay. Uncle Bill Durham says, remember that neighbor that could never set the clock on his or her PCR clock? Same thing. And I know I was just joking.
Yeah. No, doing this part is the easy part, right? What he could never figure out is how to do the star alignment, so this thing would actually track. He was told,
Okay. Uncle Bill, 60 millimeter f 5.8 equals 350 millimeter focal length.
That's what it says on the lens here. Let's do it. All right, 60 times 5.8. That's 348 millimeters. 348 millimeters. It's 2 millimeters off. So, yeah, poor quality, these Meades, right? Yeah, either the focal length is a little bit wrong as specified here, or the focal ratio is a little bit wrong, or the diameter is a little bit wrong. I mean, those are sort of your 3 variables there. So yeah, it could be any of them. But yeah, what my coworker couldn't do is the star alignment. What you have to do is you have to set this thing so it's level, right? So it points level.
Okay.
And then it has to point north, right? And what he was doing is he was taking a compass. He was taking a compass and pointing it north. And it's like, dude, no. Magnetic north and true north are significantly different. I don't know what they are. It sort of depends on, your location on the Earth. Yeah, so don't use a compass. In the north, we have the North Star. And then, of course, he said, well, the North Star isn't exactly north. And it's like, okay, yeah. But
okay. Manual star alignment is more difficult for a beginner to do, says Automata. Andy Conway says you got to set up a line align it up with 3 stars, and it know that we're in the world. And Uncle Bill Durham probably rounded it up the numbers.
Yeah, yeah, and actually, Andy, you can do a 2-star alignment, and that'll get you pretty good actually.
Now I have a
To
question. What
Yep.
you gonna do if WWE shuts down and you can't do your ovulations right then at the moment? You're gonna be like,
WWV is not going to shut down. No
I don't
way.
know. That's what I'm hearing from some other people.
Yeah. Nah. It's too much needed and too much used um, to go away. Yeah. It just won't. Even if um, sort of the department that runs it now um, stops, somebody else will pick it up, right? It 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 really. I mean, yeah. I mean, it always could stop, right? But that is so incredibly unlikely as far as I'm concerned. That nah. I don't think that that's a concern whatsoever. Cheers to WWV.
Yeah. Now, have you ever used Call to Listen?
Call to listen.
Yeah, like all you gotta do is just dial a number and you're just listening to radio on the phone.
Oh yeah. Does that exist still?
Yeah. I was with. I can listen to WRMI, Radio Romania, the BBC.
Oh, cool. Okay. Yeah, I had no idea that that was still going on. So cool. Anyway, so yeah, the hardest part is just learning the procedure, right? Once you have procedure and know what buttons to push here, um, you are set, and you just have to practice a little bit, and that's exactly what I'm going to tell him. I'm going to show him, you know, um, what to do, and then I'm going to have him do it, right? So I can watch him and maybe have him do it a couple of times. After he does it a couple of times, he's going to start realizing that this is pretty easy, right? Because this thing actually does things all by itself, right? It's all you have to do, right? Is you have to set it so the tube here is um, horizontal, which you can, these things actually unscrew. So you can move these things around, right? So you set this, and I know it's a little bit hard to see.
See, it's got that clutch, right?
It's got a clutch, yeah, which my telescope doesn't have. Ah. Um,
Yeah, that would suck.
yeah, so set it to the horizontal, and then you turn it north, right? And when it's north, you lock that down, and then you can start with your procedure, where it has like a little computer in it, right? And you have to tell it the date and the time, and um, think that's it. I'm gonna have to look at the procedure again, um, and then it
Alright.
actually.
No, it's what Troy Rancher always says. You can separate the men from the boys.
Yeah, yeah. So
Problem with these go-to scopes and peace like our neighbors is they often expect the scope to do it all without the user learning. That's an instant fail.
instant fail, instant fail.
Yeah, and like an epic fail.
Yeah. But the what we have to do on our end is pretty minimal, right? We basically have to tell it, you know, what time is it? and some kind of an initial setup, right? And as long as that's done, these things you can do everything else.
Now, can you do now? Can you put your webcam or your CCTV? Okay.
Yeah, and that's actually what I'm going to do tonight. I'm going to put the webcam up on this guy. I'm going to go out, do a star alignment. I haven't done a star alignment on this before, so I've got the procedure. I practiced it a couple times, here, uh, and yeah, I mean it's extremely easy. Uh, and so yeah, after this live stream, I'm going to take this guy out, and I'm going to do a star alignment. I'll put the webcam on it. I'll live stream, and yeah, and yes, Atta, it does. It does a two-star um, two-star alignment. So
Now,
it
what's the difference between a 2-star alignment and a 3-star alignment?
a three-star will get you a little bit more precision. Um, Actually, when I was doing it um, way back when, we would do 20 or 30 stars for extremely precise. The more stars you have, the more precise your model of the sky is, and so your pointing is going to be better. And yeah, but 2-star is actually, well, sort of the minimum. I think. Don't quote me on that. Um, but yeah, I mean, 2-star most of the time is pretty good. 3-star is really
Now,
really good.
the more stars you put in your alignment, the better, right?
Yeah, and I think these systems, at least my telescope, right, that one, and this one also, you're sort of limited, right? I think this one can do a 3-star, I think, and I think mine can do a 3-star as well. But you can't do a 10-star. You can't do a 20-star. I think you're limited. I think to 3. Now, if I'd be able to get into the firmware and mess around with that a little bit, I'd be able to change the code and do all that. But I don't think Celestron or Mead is going to give me their source code. So, oh well. Hey there, Hip. Nice to see you.
Hey, hip hip.
Spectacular Raptor. So yeah, I'll be doing this right after the live stream, as it does look like it's pretty clear out there. So yeah, I'm probably not going to do very much. Probably going to look at Saturn. With the webcam, I'm sort of limited in terms of what I can do. I mean, I certainly can't see like galaxies or anything like that. Um, I'll try. Well, we'll do a little bit of a test and see what the limitations of this thing is. But definitely look at Saturn, maybe look at Mars, maybe look at a couple of binary stars. That's about it. It'll be a short session.
Now, can
I
you
just
look
sort
at
of want
galaxies with your CCTV or no?
with the CCD camera, yes, but I need to do long exposures to do that. So yeah, and actually, yeah, it's CCD. That stands for Charged Coupled Device, CCD, and those have been around for 40 years, 50 years or so. I think since maybe the 60s or the 70s or so, and they've much improved over that time. Um, so uh, now putting that camera on this scope would probably be pretty problematic because this is a pretty small scope, doesn't have a lot of weight to drive. sort of built
Oh, so it's going to
for,
be hard with your CCT TV
yeah,
with your uh, man, that's crazy.
yeah. I'm
Now,
definitely
if you're
not.
planning on doing a live stream, when and UTC is going to be expected?
As soon as I can get out of there after this one. So whenever this one leaves, I don't know, 10 minutes or 15 minutes afterwards, easy.
Okay, give about 10 or 15. Okay.
Yeah, something like that. So yeah, he'll have to do a realignment every time anyway. So yeah, I think that'll be a little bit fun. And since it's clear out, heck yeah. All right, well, cool. Let's move on. I'm going to. Oh, the one problem with this scope that I definitely do not like at all is that this is only battery powered. So this only runs on batteries. There's uh, no way to plug this into the wall at all. So that's a to me that's a big negative, because as as the battery power goes down, it's there's a possibility that the motors are going to change behavior. It's not going to be able to track. It's not going to be able to point. Uh, and yeah, you got to keep feeding this thing, and it's like, yeah. So
And it's a rechargeable, or you got to put batteries in it every time?
you got to put new batteries in it every time. So yeah.
What kind of batteries?
Mm, I think I think the battery compartment is actually right here. Let me look. I think they're like triple A's or double A's or something. Let me look. Oh yeah, it's like a battery pack. Right.
Computer drawings has several wide field opportunities to catch 21p near messier objects this month.
Yeah. I think as noted here over a week ago or so, comet 21P Jacobini Zinner is up and nice and bright in the morning sky. Right, you're not going to be able to see it now. You've got to wait until I would say probably after midnight at least. But yeah, it's going through the constellation um, Auriga, and there's a lot of Messier objects in that.
Okay, there's M36, M37, and M35, and then it goes through the Rosette Nebula on the 29th.
That is going to be some sweet photography shots, because the Rosette is this beautiful in.
I think Fraser Kane should try to attempt that shot.
Oh yeah, for sure, he probably will. The Rosette, in sort of visible light, is this beautiful red, pretty big object, right? And the comet, right, is going to be, whites and greens and all that. It's going to look really sweet. So yeah, check out Comet 21P Jacobini Zinner. It's GIACOBINI hyphen Zinner, ZINNER. Yeah, definitely check that comet out anyway. If you've never seen a comet, this is relatively bright, right? I mean, you can see it through a pair of binoculars, no problem at all. And yeah, everybody's gonna everybody's gonna be looking at that for sure. That'll be a nice shot for sure. and it'll, it's it's so close to us. The comet is so close to Earth, that um, it actually looks like it's moving, excuse me, pretty fast. So it's going to fly through the rosette, probably in a number of hours. So your timing has to be really really good there too, right? Yeah, hours. Yeah, I mean we could look it up, but yeah, it's the rosette is big, but it's not that big. So yeah, it's only going to be a few hours, where it's actually going to be like uh, right in the nebula, and yeah, I'd actually like to confirm that it's actually going to be going through it. Um, um, Uncle Bill, if you say that it is, then that's probably true. So, um, but yeah, I'd like to confirm that and see exactly when, right? Because um, there's a possibility, right, that depending on what side of the planet you're on, right, you're not going to be able to see it when it's really really close. But even one day or so, maybe 2 days before and after, that is still going to be a great, great, great shot. So yeah, very cool, very cool. I haven't heard anything if uh, if this comet is getting any brighter than what it should be, if it's doing any kind of outburst or anything else. I'm trying to get this battery pack back in here. It's not behaving, so I'm just going to put it in there like that for now. Um, so yeah, haven't heard if it's going through any kind of outburst. It's at perihelion. The closest it's going to get to the sun, I think, is September 10th. Right, so that's just a few days away. What, 6 days away um, from this time, at least, which is the 4th. So yeah, very very cool. And like I said, I'll be taking this guy out and doing an alignment, and I'll put the webcam on it, and we'll look at a couple things. Probably not going to spend a
Okay.
lot of time.
Issues with my stellarium. It won't display any hint, label, trail, or orbit for comments, so I can't make good charts. Probably his OpenGL is not up to date
I see.
or not up to snuff.
Not up to snuff. Yeah, yeah, that's cool. There are other ways. If you went, slightly more complicated ways, you could go to the JPL Horizons website, um, and get an ephemeris for that comet, and be able to plot things that way. Um, so yeah, and I'll bet that if you poke around to like
Now,
sky.
if Uncle Bill was actually at the panel right now, he would teach me how to install Solarium, how to get the plugins and stuff. Cause right now I'm using Ubuntu, and I'm not sure yeah, he uses Assume so he should like teach me how's it done and stuff.
I think I'll talk to him, but I think having a little um, tutorial on Stellarium, or at least parts of that might be kind of fun. So think about that, Uncle Bill, and you can get back to me on that. Yeah, cool. So anyway, so I'll be doing that later today. I guess what I wanted to do is um, finish up with Messier 90. So that's a galaxy that we started to look at yesterday and didn't get all the way through it. So I sort of figured, let's let's finish up with that, sort of proper like, and um, uh, yeah, finish up with M90 today. How does that sound? So I'm going to share my screen like that. Hide that. And just FYI, archive.org has not updated their astronomical list for today yet, at least last time I checked. Now I'm going to reload this and see how it says it's for Monday still. So this is yesterday's news. It's like, it's old, right? So I'm
I don't,
going
I don't
to,
think it's going to update because it's still Labor Day here, local.
yeah, but if that were true, they would have not done it for Monday, right? So maybe you're right though. But here, I'm gonna do that and see if this. No, it's still for Monday. Yeah. So you might be right, Bobby. Maybe they, in some kind of wisdom, they decided that they would list, the new ones for Monday, but not the new ones for Tuesday. So I don't know. I don't know. Some people. Let's see. Okay, so I've already loaded M90 into Simbad. So this is sort of where we were yesterday, right? And this is what's called a galaxy that has a active galactic nucleus. It's just a very, very busy system. Um, yeah, we should probably get into the AGNs and CFERTs and all of that at some point, just to dive into that a little bit deeper. Suffice it to say, this is a galaxy that has a nucleus that is just extremely active. Um, the nucleus of the Milky Way is, pretty benign. Not a lot of activity going on. At least, nothing that we've observed. Um, but when we look out and look at other galaxies, we notice that some of these galaxies have nuclei that are quite active. And by active, what I mainly mean is that uh, their light output is varying, um, maybe at different wavelengths, right? So maybe in like the radio, it's extremely active, while in the visible, it's not incredibly active. So it's just that their light um, output is varying, and I'm sure they have theories about that. I'm not too up on those kinds of things, and that's probably why we should probably dive into these a little bit more at some point. But for now, let's just focus on M90. So pretty bright, right? UB and V are sort of in the visible range. So, 10th magnitude galaxy, that's pretty bright. Pretty bright. As you move into the infrared, J, H, and K, it looks like they even get brighter, right? So, yeah, U and G, I'm not quite sure why those are so faint, because U and G are both sort of in the visible range, but they're showing up as 15th magnitude objects. So I'm not quite sure about that. Not quite sure. R, I, and Z are more towards the infrared, and yeah, those are a little bit brighter for sure. So they're calling this an SAB galaxy. So S means spiral, and then I'm not quite sure what AB exactly means, but it's an SA, right? Oh, SAB might be a bar. So possibly, yeah. Let's expand this view a little bit so we can sort of see more of this galaxy. Yeah, I think that's exactly what they're talking about.
So,
Which
Uncle Bill, so if I just use the default repositories and use Stellarium, would all the plugins be there, or do I need to find or have a way to do the plugins?
I think, yeah, you'll have to. You guys will have to hook up a little bit. Hey there, Crystal. Nice to see you in the chat.
There's I Gruesome too.
Oh, hey there, I Gruesome. Nice to see you also in the chat. This is your first time in the chat? I don't remember. Don't remember if I've seen you in here or not. Anyway, we're looking at Messier 90. It's a galaxy. I was just talking about the fact that this is a spiral galaxy that actually has a bar. Kind of hard to see because of the angle here, but it does have a bar, and then coming off of that bar are these spiral arms, right? So we're not looking at this face on. We're sort of looking at it, at some kind of an angle. Um, so yeah, here's one arm here, and here's another arm here, and you know, lots, well, more complicated than that, of
Hey,
course.
thanks, Uncle Bill.
No muss, no fuss. Yeah, setting up Stellarium not is definitely not easy, but it's also not really complicated, right? I mean, it's sort of, you sort of have to tell it things, but it seems to know, where to go and find stuff and all of that. So, yeah, Stellarium is awesome. Yep. Plugins, plugins. So yeah, so that's why they're calling it an SAB. So that A just means that these arms are pretty loose, pretty open, and then this B means there's a bar. All right, let's move on here. So here's all of its different names, lots of different catalogs. These are basically just catalog names where they've they have some kind of instrumentation, and they are looking for some kind of a feature, right? Either, I mean, it can be lots of things. Um, and if they find an object that sort of meets all their parameters, then they'll put it on their list and it becomes part of a catalog. And so here's all the catalogs. Um, and so it has a bunch of different names. Messier 90 is, of course, one of them. It's also known as New General Catalog 4569. So yeah, very cool. All right, let's keep going here. So wow, lots of references. 746 references. These are papers. These are scientific papers where supposedly, at least, this object is mentioned. Either, well, because that's the focus of the paper itself, or it's just, they're studying some kind of galactic phenomenon, and this galaxy uh, has that phenomenon going on. All right, let's see how far away this bad boy is, and also how fast it's moving. Okay, so yeah, it's pretty good agreement there, except for that last one. Oh, sorry. Except for that last one there, but if you sort of exclude that one, what we're seeing something like 17 million parsecs away. So let's see, a parsec is 3.26 light years. So that's a million of those. So 3.26 times 10 to the 6th is 1,000,000 parsecs. And then let's multiply that by 17 to get how many light years away it is. So, yeah, pretty close, right? 55 million light years away, which is, sort of neighborhood. Um, it seems like a long way, right? Because 1 light year, right, is something like 6 trillion miles, right? And so you have to multiply that by 55 million to get, you know, that many miles. I mean, it's really far away. But in terms of galaxies, right, it's sort of in the neighborhood. And that's why when you look at it, it looks so big and bright, right? And I would venture a guess that this is actually part of what's called the Virgo cluster. There's a cluster, in fact, a supercluster of galaxies that actually the Milky Way is a part of. Um, and as we zoom out here, you'll be able to see more galaxies, I would think. Yeah, so there's an elliptical over here. There's a little one over here. Let's see if we zoom out a little bit more, we might be able to pop more in. Of course, this is M90 itself. Okay, well, here's a big elliptical down here, sort of the same size, right? Oh, here's a really big one over here. Here's a couple small ones. Here's some over here. See, as we zoom out, of course, we're seeing more and more of the sky. So I'm going to zoom way out here, and you can start seeing that there are just galaxies, right? There's galaxies everywhere. And this is part of the Virgo cluster. It's called the Virgo cluster because, at least from our point of view, it happens to be in the constellation of Virgo. So, yeah, this cluster actually is made up of thousands of galaxies. And as I previously said, this cluster is part of a larger supercluster um, in which our galaxy is actually a part. So in some small way, we're a part of this as well. So so yeah, lots and lots and lots of galaxies around here, lots of galaxies. But you can also see lots and lots of stars too, right? So all of these stars that we're seeing here, these red things, and these smaller ones that might look a little white or a little bit blue, all of that. So those are all stars in the Milky Way, right? So we're sort of looking through the Milky Way to these other galaxies that are you know tens of millions of light years away or further, right? And it's amazing, right, to think about the fact that there are this fuzz, right, isn't gas. Well, it is gas and dust and stuff, but what you're mainly seeing here in this fuzz is stars, right? Stars that are part of this galaxy, Messier 90, and it's just so far away that we can't really differentiate, the individual stars. It's just too far away, so it looks like a fuzz. But as you can also see, right, we are seeing gas and dust and all kinds of muck and everything else in there, right? So yeah, and actually we were looking at this galaxy um, with the HST yesterday. All right, we went over to the HST site, the Hubble Space Telescope site, and grabbed a um, um, couple images there. Was playing with the colors and all that kind of stuff because this is you know these images are long exposures, right? So if you were to go out and look at this with a telescope, right? you would not see it like this, right? You would not see all this. These are long exposures. These are, minutes or hours long exposures. Um, what we would see with a telescope, right, is just sort of this central bright region. You might be able to see, these dark lanes, maybe, maybe, but with a telescope, with your own eyes, you're not going to see any of this stuff at all. It's not. It's just not going to be there. A lot of people are disappointed, right, when they look at a galaxy because they're sort of expecting to see this, right? And there is no way that you're going to see that unless you put a camera on there and do a long exposure, right? If you do a long exposure, absolutely, absolutely, you will see this or something, close to this. Um, but with your own eyes, no way, not not a chance. You'll sort of see, the central bright region, and that's about it. And it looks like a gray fuzz. That's all. That's all it looks like. But even that, right? I mean, you're seeing it with your own eyes, which is very cool. It's very, very cool. And you know, consider the fact that all of this fuzz is stars, right? You're talking about hundreds of billions of stars. So, wrap your head around that, and I mean, it blows me away. I mean, I've been in this my entire life, right? 40 plus years, and you know, to think about that and to realize what we're seeing here it's just awesome, right? It's just absolutely incredible, and it's absolutely gorgeous, right? On top of that, it's just absolutely beautiful. So yeah, I think we're probably seeing some galaxies here in the background too, right? These are smaller, which either means that they are intrinsically smaller than this guy, or they're the same size and just further away. And educated guess, they're probably about the same size as this guy, right? So that means they're further away. And so it's really neat, to think about the fact that, we're looking through our galaxy, and then we're looking through this galaxy to see these galaxies back here. It's very cool. It sort of hopefully, gives you a little sense of depth, right? So this guy, Messier 90, is between these galaxies and us. And, thinking about that just makes me dizzy. It's a good kind of dizzy. Now, this is some kind of a um, irregular galaxy. It looks like. Not quite sure what's going on there, but you see how nice and organized, moderately um, organized this guy is compared to this one, right? And this one doesn't seem to have a nucleus of any sort. I think this bright thing is probably a foreground star, right? So that's a star, um, uh, you know, just so happens to be lined up right. But yeah, there's some interesting things going on in this galaxy. Lots of dark stuff. We got these brighter things in here. Maybe where stars are being formed. Kind of weird shape too, right? Like I said, it doesn't look like it has any kind of nucleus. Any kind of bright center, right? It's just sort of a blob. So I'm not sure if this is like a companion galaxy to Messier 90. Not quite sure. Or again, you know, if it's some kind of background galaxy. Kind of cool though. Nice color, interesting structure there. Um, don't know if that's been studied or not. All right, let's go back to this guy, and I'm gonna check the chat really quick here. Make sure there's no mayhem. Um, yeah, yep, supercluster. Fuzzy Wuzzy was his name. Yeah, yep, yeah, and I think 55 million light years away. As I said, that's sort of neighborhood. Um, so yeah, not really really far, not really really close either. And it looks like there's pretty good agreement here in terms of how fast it's moving. Um, I guess you'd call that um, like away from us, right? 220-ish kilometers per second. It's moving away. That's why it's negative here. So not a huge amount of motion. Um, I've seen faster, for sure, for sure. Let's see what else we got here. Observation logs. Those are sometimes kind of interesting. um, don't know if they're gonna show off anything too exciting. A lot of this stuff is kind of hit and miss. Okay, so these are spectra, right? So these aren't actual um, images. These are looking at the spectral response of this object. Um, so here is the wavelength down here, and as you can see, it's in microns. So we're actually getting into, um, well, definitely on the infrared. And as you move into like 10 microns or stuff, you're actually looking at the thermal infrared. You're looking at what we would call heat. And as you can see, there's some structure here, right? This is flux or brightness versus wavelength. And as you can see, at about 11 microns or so, there's a brightening here. So that is being caused by something, right? So there's lots of interesting structure here and all that. Spectroscopy is really complicated and extremely useful. So yeah, I think over time we'll definitely be able to pick up a lot of terminology and a lot of good understanding of spectroscopy. I'm not going to focus on it too much because it's a complicated topic. Um, you've got to be well into the science in order to understand what these things are doing, and I definitely don't claim to understand all of it for sure. All right, let's move on here. Want to see? Let's quickly kind of go back to the HST archive and see if there are any more pictures, images, I should say. 90. So we looked at this last night, and we'll look at everything again because there was quite a few, but I sort of stopped a little bit early. So Nick Moss has looked at this. This is a infrared camera, not really high resolution, but pretty good camera anyway. STIS, oh, I forget what STIS stands for. Should we look at that? That's yeah. Let's just see what that looks like. pretty long exposure, 2,861 seconds at a wavelength of 6581 angstrom. So that's pretty red, right? That's around actually what's called the hydrogen alpha area. Oh, okay. It's a spectrum. Cool. So there's another spectrum showing some spectral features. Not quite sure exactly what all these are. As I said, H alpha is in this area. Not quite sure which one of these it is, if any. This actually might be it right here. I don't know. Most of these wiggles, most of these dips, and all that are significant in some way. You have to be a spectroscopist to really uh, know what's going on there. Okay, so that's STIS. Let's stay away from that because we want to look at pictures. We've picked two for sure. So back in 2001, they took this one. Let's see. Oh, there we go. That's pretty. So that's the same object, right, as what we're looking at here, just with the HST. So this is just raw HST data. Amazing structure, though. Isn't that just incredible? So as you can see, the field of view here has changed, right? We can go back and yeah, we can do this. And as you can also see, the resolution is much better too. Let's see if we can see these two stars in the HST image. All right, one's over here, one's over here. Let's just see. Yeah, kind of hard to tell because we're seeing a lot more stars too, right? With the HST, we don't have the blurring effects caused by the atmosphere, so we can see a lot more details that we really can't
Yeah.
see here at
Yeah,
all.
I like to thank Uncle Bill for directing me to Stellarium. I'm still figuring things out, but I'll get it done.
Yeah, yeah. As I said, it's pretty intuitive, so pretty easy to use. Pretty easy to use. Beautiful structure here, though. Do we have another one of those at a different wavelength? We do. Oh, do we? 606. Uh, no, these guys just did two exposures, same wavelength. Um, here's some down here though that were taken at different wavelengths. 547, 656, 791. So sort of, I mean, 791 is really red. 656 is quite red, and 547 is more towards the green part of the spectrum. So let's just take a look at these, maybe. Oh, that's kind of cool. All right, well, should we do this? Yeah, I think we should. We're here. So let's grab this one. So this is the shortest wavelength one. Okay, so we did this last night too with a couple other images, but let's just let's call this one A. Call that one A. So that was at 547. Let's grab the 656 one. Let's grab this one. So kind of interesting, right? I mean, it's changed significantly. So we'll grab that one. So we'll call that 2A. And we'll look at the 791 also. See what that looks like. So yeah, I'm not quite sure why this 656 looks so terrible. Let's look at this one, right? It's the same observer, same exposure time. Let's see if it looks as bad. It does. Yeah. Don't exactly know why. The exposure time is about the same. Same instrument. Don't know. Okay, well, let's grab this one. And we'll call that, well, I guess we'll just call it 3A. And let's fire up GIMP and make a quick RGB out of this bad boy, just to sort of see what that looks like. So I think what I'll do is I'll assign the longest wavelength red, and then the shortest wavelength blue, and then the one in between I'll make it green. Sound like a deal? Okay, so let's load these up. One. Oh, I'm going to put you down for a sec. I'll load them all as layers. And then let's go into RGB mode. And I'm going to invert all of these. Makes the colors pop a little bit more that way. So yeah, I don't know what's going on with that one. That's kind of strange and annoying. It's going to potentially mess up my picture here, but we'll keep going. Okay, so let's see, the reddest one. Oh, I don't remember the order I did it. Okay, so this is the least red one. All right, so let's make that one blue. I think that was the first one we did. So 1A, let's make that one blue. Oh, we need to add these up.
Is this still M90?
This is still Messier 90, yes.
Okay.
Just having some fun with HST. So let's make that blue. And let's make this one green, because that was the middle one. And we'll make this one red. Oh, that's not too bad. Yeah, the green really is kind of annoying. Let's see what we can do with that. What, wrong one? This one. I don't know if we're going to be able to do much with the green. Kind of painful. Zoom out a little bit. You can see the whole thing. Yeah, unfortunately, probably not going to be able to do much with that at all. At least not in the short term here. What we can do,
I think it will come close.
yeah, and you know, at this point, it's sort of a matter of artistic taste, too. So, you know, and that's very subjective. That's very, very subjective. So I'm just going to sort of set this, I'm going to turn the green down a little bit so it's not that obnoxious. And then let's combine these and play with the brightness and contrast a little bit and see what else is there. Okay. So we're sort of diving into the muck here a little bit, but kind of cool. Kind of cool. One, you know, I mean, we could spend hours and hours and hours and days and days and days, right, messing with all this stuff. And this is some of what professional astronomers do, right? Not, I mean, maybe not exactly this, but yeah, a lot of time is spent uh, going through all these things. It's pretty, pretty crazy. So, all right, well, cool. Wow, it's already 3:11 UTC. That's amazing. So, I think it's about time to wrap this live stream up for today. That's one of the cool things about doing a daily live stream is that I'm in no hurry at all. It's like, what we do, and hopefully it's a little bit fun. It's definitely fun for me, and that's why it's so easy for me to do this every single day because it's just great fun, right? Um, so yeah, but I think I'm going to wrap this up for today. Excuse me. Like I said, I'm going to take this scope out. Um, am I actually? Yeah. So I'm going to take the scope out pretty much right now. Set up, and you know, for what it's worth, um, if you'd like, come join me. I'll I'll do the star alignment, and then we'll look at a couple of things, um, and then call it a night. So it'll it'll be sort of a short live stream out there, but I sort of want to see what this thing can do. I'll put the webcam on it, and so you can take a look too. And yeah, I think that'll be a little bit fun. And actually, I haven't looked through a refractor in quite a while. So yeah, I think that'll be a little bit of a treat too. So all right, you guys, thanks for coming in. I will see you. I'll be here at least in a little less than 23 hours from now. Feel free to join me then. You can join me anytime you want. If you want to check in, each day, I think that is really, really, really great. If you want to check in every week, every month, whatever you are welcome to come in anytime you like. So, all right, you guys, I'm going to get out of here for now. Take care, and I will see you on the spin. See you later. Bye.